this tutorial video, we're going to talk about one-step inequalities with addition and subtraction. So, before we get started with the actual problem, let's go ahead and define what is an inequality. So, inequalities are different ways to compare numbers. For example, let's say that m is less than 3. In order to make this statement true, and this is less than, because the first value is less than the other. In elementary, you guys learned them as the alligators, and so the alligator eats the bigger number. So in order for this inequality to be true, then the only values that could work for m would be values that are less than 3. So it could be 2, it could be 1, it could be -5, it could even be a decimal like 1.5. And so all of those values that are less than 3 could be picked to replace m. Okay, if m is greater than 3, then this is greater than, you would have to pick values that are bigger than 3. Even 3.5 is bigger than 3. 4, 5, and we can keep on going forever and pick any value that is greater than 3. We also have m is less than or equal to 3. And the difference between this one and the first one is that you can also include 3. So you can pick values that are less than 3 or equal to 3. So that means you could pick 3. So 3 could go here because 3 is also less than or equal to 3. And there is greater than or equal to 3. Which again, it would be almost like the second one, with the exception that now you can include 3. So 3 could also go on here. And there is not equal to 3. So any value that is not equal to, and we won't be using this one very much with inequalities. And then m is equal to 3. Which it has to be 3 and nothing else. So those are all the different inequalities. And so the ones that we are going to work with the most with one-step inequalities are these 4. And so we will begin with our first example. Okay, so with our first example, I have m plus 5 has to be less than or equal to 3. Okay, and so in this particular problem, it's just like solving one-step equations, which the only difference now, instead of an equation, you have an inequality or an equal sign, sorry. So I'm going to start with drawing a model, and there's my balance beam. But instead of having an equal sign, I'm going to have an inequality. So my inequality is less than or equal to. And so I'm going to use pouches and coins. And so my pouch is m, because I don't know how many coins I have in my pouch, plus 5 positives. Okay, and it has to be less than or equal to 3 positives. Okay, so the goal is to figure out how much is inside the pouch. And yes, I know this is probably one you can solve in your head, but I want you to understand conceptually what is happening to this particular inequality. So to get my pouch by itself, I have to get rid of these 5 coins. So to get rid of 5 positives, I'm going to add 5 negatives. Okay, but I've unbalanced my beam, because what you add to one side, you have to add to the other to conserve equality. or to keep it balanced. Okay, so 1, 2, 3, 4, 5. And so these coins are going to cancel out and equal 0 pairs, which will just leave me M by itself. And here, only 3 of these are going to cancel out. And I'm going to be left with 2 negatives. And so when we're solving it algebraically, M plus 5 is less than or equal to 3. Then you follow the same guidelines as you would with the equations. And so here I like to separate my sides. And so M plus 5, to get rid of this 5, I'm going to take away 5. Or 5, I don't know why I put 6, sorry. And do the same thing on the other side. So this is going to go away. I'm going to be left with my M by itself. Is less than or equal to, and 3 minus 5 is negative 2. So you can see that both of these match. And so that checks my work. And so finally, the next step is to graph my solution on a number line. So my solution is M is less than or equal to negative 2. So I'm going to draw a number line with only 3 values. And my middle value is negative 2. Then the value that is to the right of negative 2 is negative 1. And to the left of negative 2 is negative 3. And just like we know number lines, even though this is a negative value, values on the left are smaller or less than, and values on the right are greater or larger. Okay, so the next thing about inequalities when you're graphing them is what kind of dot you're going to use. And so if you are including 2, okay, so if your value is going to be equal to 2, like this one's equal to it, then you're going to have a closed circle, because I'm including this number. I'm including 2, so I'm going to go ahead and shade it in. And my M, or my number, has to be less than or equal to negative 2. So the numbers that are less than or equal to negative 2, and these are less than, are to the left. And so I'm going to draw a little number line with an arrow, because I can pick any value that is less than negative 2, and it will make that inequality true. Okay? And so this line with the arrow includes every single possible value that is less than 2. Okay? And so now we're going to go ahead and we're going to do an example with subtraction. So we'll use P minus 3 is greater than 7. Okay, so that's our inequality, and I'm going to show you again using a model algebraically, and then we're going to graph it on a number line. Okay, so here's my balance beam for my model, and my inequality is greater than. And so on here, I'm going to use algebra tiles. So here I have P, which is my variable, and then 3 negatives, because I'm taking away 3. And that has to be greater than positive 7. All right, so it kind of works the same way as we did our pouches. Okay, we want our variable to be by itself because we want to know how much is in that P to make this inequality true. So in order to do that, I have to get rid of these 3 negatives. And to get rid of those 3 negatives, I need to add 3 positives. and that's going to give me 0 pairs. But now I've unbalanced this, so I have to do the same thing over here. And notice that I added 3 positives. So I have to add 3 positives to keep it balanced and keep them both sides the same. Okay, so here, since I added the 3 positives, I don't have any 0 pairs, so they're not going to cancel out. So they're all friends, they're going to party together, and I end up with a total of 10. So P has to be greater than 10. And to solve it algebraically, okay, so P minus 3 has to be greater than 7. Again, I like to separate the sides. So to get P by itself, I add 3 to both sides. And so that gives me P is greater than 10, which both match and make it true. Okay, and so the final step is to graph it on our number line. So my solution is P is greater than 10. So here is my number line. Here's 10. The value to the right is 11, and the value to the left is 9. And again, this side is smaller, and this side is larger. So, since P is greater than 10, that means I cannot include 10. Since I cannot include 10, my circle is going to be open. And it's going to be open because it does not include 10. And so my P has to be greater than 10. So the values that are greater than 10 is 11, 12, and so on. So my arrow is going to go that way. So that is my graph on the number line. So this is P is greater than 10. Okay, so this concludes this tutorial video.